Hey all, I'm Anurag. I'm the product manager here for Snowflake Developer Platform and APIs.
And hey everyone, my name is Gilberto. I'm a developer advocate here at Snowflake, and I'm joining Anurag today to show you a lot of cool demos around building apps with Snowflake.
So quickly, let's go over the agenda for today. We'll do a quick overview of what's new with Developer Platform, what new features and products we are offering as part of it. And then we'll show some quick demos around our custom APIs with Python connector, Snowflake CLIs, and a couple of Python API demos. And then we'll quickly wrap up with a call to action in the end. So let's quickly talk about what our vision is for Developer Platform as part of Snowflake. We really want to empower all our developers to build really great developer experience on top of Snowflake across workloads. Here you can see a Lego block of all the bits and pieces we're building across different workloads, which will enable you to really build really great developer experience on Snowflake. We have introduced Python APIs, which we are kind of making it across Snowflake, along with a lot of other developer tooling, which we'll talk in the following slides. One of the big features which we are launching right now is our Python APIs. The focus is to make sure we are spreading Python everywhere, which includes having a unified first-class Python APIs across our workloads, which includes our data engineering resources. So you will be able to do management of tasks and DAGs with Python. You'll be able to use Snowpark Container services with Python. And along with that, we are adding more support for resources like tables, schemas, database, warehouses, which will enable you to declaratively define these objects in Pythonic way and be able to do create and updates, alters on them all through Python itself without going through the SQL APIs if not needed. The next one, which we are kind of really excited about, is Snowflake CLI. This is an open source command line tool, really focused on app-centric workloads. So you will be able to use really simple CLI commands for building apps with native apps, Streamlets, Snowpark, and all in a fashion where you can really build really great automations and CI/CD flows with CLI. The next one, which is a pretty top ask from our developers, is Git integration. So we kind of really working to build a native Git integration into Snowflake, which enables you to view, run, edit, and collaborate within Snowflake experiences with assets that exist in a Git repo. Along with that, this becomes a single source of truth for your artifacts to work across workloads with Snowflake. And then we are planning to launch the PUPR soon for it. It's currently in PRPR. The next one, which is already live, and we have seen a lot of good kind of integration built on that, that's our SQL REST APIs. This is a REST interface which allows you to submit SQL commands over HTTP endpoints, and it supports our DDLs and DML statements. And this is really useful in use cases where the drivers cannot be used or loaded, and really helps you build really custom REST endpoints, migrate existing applications built for APIs, and then integrate with application that already provides a REST interface through a partner tool or a partner service. We also provide an API playground, which enables you to use our SQL API live with our Snowflake account. There's also an open API spec, which is available on Snowflake Lab, which you can use along with our Postman collection, which is published on developer.snowflake.com. And this really enables you to quickly get started and start using our APIs using the open API spec. Last but not least, we know our drivers are something which is kind of highly used across Snowflake. We see millions of downloads for our Python, .NET, and JDBC drivers. And we have been making sure that they're best in class and they're highly performant. Some of the key features we have added recently, we have done a major redesign for Python drivers, and we have added support for nano arrow integration. What it enables is it kind of really bring the whole size of Python connector to less than 5 MB so that it can be easily kind of hosted on Lambdas and Azure functions and build custom APIs. Along with that, we are adding support for Unistore. So as Unistore capabilities are getting to PUPR, you will be able to use our drivers and easily access Unistore tables with your existing drivers itself. Now we'll hear from Gilberto, who will show some really great demos which we have built for you. Over to you, Gilberto.
Thanks, Anurag. So let me show you a few demos that demonstrate how you can use some really neat tools to build applications with Snowflake. And the first one that I'm going to show is an application that uses the Snowflake connector for Python and Snowpark for Python to query some data that's in my Snowflake account. And so what you see up here is a very simple Flask app. And if you're not familiar with Flask, it's a web application framework for building apps with Python. And I'm first going to go ahead and start the app, and I'm going to run Python /appy. And you'll see here that the application is now running on port 8001. So I'm going to navigate over to a browser, and I'll hit refresh, and you'll see that it's running and we're returning, hey, nothing to see here. And that's intentional because the default route that we've defined displays this message. But if you navigate to /test, you'll see this UI here. And let me quickly explain this UI before I go into the code that powers it. So this is a very simple API tester. And what this allows us to do is query the sample Snowflake data that comes in all Snowflake accounts. And I can choose my method for connecting and querying here. So I can choose either the Snowflake connector for Python or Snowpark Python. And so there are a couple of ways that we can query this data. We can query for the top 10 customers, given these start and end dates. We can also look at monthly clerk sales. And this is a very simple front end that we built, which is some just basic HTML and some vanilla JavaScript to make these calls. So if I go ahead and hit submit, you can see we get the output from the API call here, and we're displaying it here in the front end. And what that looks like in this code is, so I mentioned the root route being the default route where we saw the message that said nothing to see here. Then we navigated to test, where we're serving up that API test HTML file. And that file, as I just mentioned, defines a front end, which is a bunch of tables and some vanilla JavaScript that calls specific routes that we've defined in other files. And so just now what you saw is me making a call using the Snowflake connector for Python. And so the routes are defined in this file, so connector.py. And I'm doing a few main things here. I'm connecting to Snowflake. So I'm starting my connection. And then I define, using a decorator, a route called /customer/top10. And then all the logic that powers the call to this endpoint is in this function called customers_top10. And what we're going to be doing here is querying for for data in a certain date range. And what we do is we can provide some optional query parameters. And so if you go back to the UI, you'll see that by default, these are the start and end dates. But we can also accept a custom start range or a custom end range. And so here is the logic that powers that. Then we do some formatting validation just to make sure that that end and start dates are in the correct format. Then we interpolate those two values into the SQL statement. So you can see here, start date, end date. And then we actually execute that against the data that's in our account, and then we return it. We do a similar thing here for the second submit button. So this is for this experience down here for monthly clerk sales. So I'll go ahead and click submit. So you can see it accepts a clerk ID and a year. The difference between this route and the previous route is that these query params are required and not optional. As you can see that because this path actually requires a clerk ID and the year. But the pattern is very similar. We do a little bit of validation against the format. Here's that SQL statement where I interpolate the clerk ID and the year, and then I run it and I execute it against the data to my account and I return it. And so this connector.py file shows how to connect and query that Snowflake sample data in my account using the Snowflake connector for Python. Now, if I go back to the app, I can change my connection method. And this time I want to use Snowpark for Python. And I'll go ahead and hit submit for the top 10 customers. I get the same output. And now let's switch over to this other file called snowpark.py, where the routes are defined and the queries are made using Snowpark for Python. So very similar patterns that you see here. We're establishing our connection to Snowflake. We're defining our routes. We have a function for the logic, all of the validations for the start range and the end end range. The main difference that you'll see is that we're using Snowpark for Python. We're referencing our table here. And then all of the transformations that you saw in the SQL statement in the connector.py file, we're now doing with Snowpark for Python. So our filters, our group by, our aggregation, we're returning just 10 of the results. Then we return it as a JSON object. And so this is all using Snowpark for Python. And personally, I think more in Python. So I love using Snowpark for Python because this syntax I'm very familiar with, and using pandas or other kinds of data frames. It feels very familiar, and I feel like I can quickly come up with some transformations using Snowpark for Python that kind of fit my mental model a bit more. And so here I have my other Snowpark route, the same kind of pattern that we followed in the connector.py file. Again, using Snowpark for Python to reference our table, to our transformations, and return that data. And so this is a neat little Flask app that shows you how you can query data in a Snowflake account, either using the Snowpark connector for Python or Snowpark Python. So that's the first demo that I want to show you. Let's move on to the next demo. So this next demo that I'm going to show you is going to use a really neat tool that Anurag and his team have been working on to make the app development experience with Snowflake a lot faster, a lot more streamlined, just an overall better and smoother experience. And so the tool that I'm going to demo in a bit is called Snow CLI, and it's a command line interface for doing all sorts of things with Snowflake. But today I'm going to demo it to show you how you can easily create and deploy a Streamlit app within your Snowflake account. So for folks who are not familiar, Streamlit is a very popular and powerful open source Python library for building really cool, neat, interactive data apps. And it's now available within Snowflake if you're on AWS in the public preview. And so what I'm going to demonstrate today is how, using the Snow CLI tool, I can create a Streamlit app directly within my Snowflake account. And I'll do that with just 2 commands. So as you can see here, I am at my Snowflake account. I'm in the Streamlit section. I don't have any apps here. And so what I'm going to do now is I'm going to switch over to the terminal, create a Streamlit app, and then deploy it here. And I'll navigate, after I do that, I'll navigate back to this account so that you can see the Streamlit app running in my account. And so let me go ahead and switch over to VS Code. I have this really small folder here called Streamlit_Snow CLI. It has 2 things. A YAML file that defines the Conda environment that I'm running, and then a config toml example file. And this is just here for the purposes of demonstration. This is how you would configure your connection to your Snowflake account. These are not my credentials. I'm just showing it here for purposes of demonstration. As an example, this is how you would do it. And of course, you would fill it in with your credentials and establish your connection to your account. So I'm going to go ahead and close that out. And so now that I'm in this folder in this terminal, I'm going to run a command, snow streamlit init. And what this is going to do is initialize a new project, and it's called example_streamlit, and you'll see it populate here in the directory. Now, I could have said snow streamlit init my project, my Streamlit app, but without providing an argument there for my own project, it generates its example Streamlit app. And so let's go ahead and open that up really quickly. It's a very lightweight Streamlit app. There's nothing super complicated happening here. It's a Streamlit app that has 2 pages. The main one, we're just rendering a page that says example Streamlit app. And then there's another page in here where we render example page as a title in a subpage. So this is just for the purposes of demonstration. Again, nothing super complicated, but I just want to show you how, without providing that argument, I get this example Streamlit app. And so now what I'll do is I'm going to navigate to that folder that was just created, so example Streamlit. And then I'm going to deploy this app into my Snowflake account. And so again, I've already configured the connection to my Snowflake account using that toml file. And so I'm going to type in snow streamlit deploy. The name of my Streamlit app is just going to be my Streamlit app. And then you have to specify a warehouse. So query warehouse is the flag that you would type in. And then I'm going to just set that to the compute warehouse that comes pre-bundled with all Snowflake accounts. So, all right, I'll hit enter here. And if we just give it a few seconds in the terminal, you should get some updates about whether or not the app was successfully deployed. And you can see here, it is. And so that's a pretty neat message that we see here. And the link, there's a handy link to the app here. I could click on this and directly go to it, but I like going directly to Snow site and hitting refresh and just seeing that app populate in the Streamlit section of my account. So I'll go here, I will hit refresh. If all went well, I should see that Streamlit app in here. So I'm going to click on my Streamlit app, and then just give it a few seconds to warm up the warehouse and to just get the app started and going here. And if successful, we should see the 2 pages that I mentioned earlier. So that top level page called app, where we say example Streamlit app, and then that sub page called my page, where we say example page. Again, nothing super complicated here in the Streamlit app, but in just 2 commands, I use a Snow CLI tool to be able to deploy a Streamlit app into my account. And it was super easy and super fast. And so that's how you can deploy a Streamlit app using Snow CLI. The next demo that I'll show you is how you can use Snow CLI to deploy a native application directly into your Snowflake account. So let's go ahead and get started with that demo. All right, so I'm going to navigate back over to VS Code. I have a similar setup here to what you saw in the previous demo. So I have a folder here called native_app_CLI. Again, a file that defines my Conda environment, an example config TOML file. And I'm going to run a couple of commands. Again, just with a couple of commands, I can deploy this native application directly to my account. I'm going to run a couple of commands here in the terminal, and if all goes well, I should be able to see this application in my account shortly. So the first command that I'll run is snow app init. So very similar to what you saw earlier with snow streamlit init. Now here I could pass in an argument to the name of my my native app, so a directory representing my app. But I'm actually going to pass in another flag here called --template, and I'm going to pass in streamlit-python as an argument. And what this is doing is referencing a native app template that is available and open source on Snowflake Labs. So there's a repo there that has a template for native applications. And what I'm doing with this command is just saying, hey, I want to use that template for this native application that I'm creating. And then now I can actually name my native application. So I'm going to create a folder called my native app. I want everything to be dumped in there. So I'm going to go ahead and run that command. So you can see here on the right, my native app has been created with a directory structure that matches that template that we pulled in from. There are a couple of things to call out here. So within the app subfolder, you'll see that I have my manifest YAML file, my setup script SQL file here. So these 2 things are required by the Snowflake Native App Framework. And the manifest YAML file just has a ton of metadata around the native application itself. So the version of this file, the version of the app, references to some of the artifacts that are required by this application. And then in our setup_script SQL file, I like to think about what happens in here as kind of grouped under roles, permissioning, and logic. And so here I'm creating this application role for this native app. I'm creating this stored procedure that is going to add 2 numbers. And so you'll see in a bit, we have a front end that takes 2 arguments. So you can type in 2 numbers. And in that front end, we will return the sum of those 2 numbers. As you can see here, it's defined using Python. We've defined a runtime. And if you want to go look at the core code powering this procedure, you can navigate to source, module-add, source again, open up the main folder, and here's add.py. This extremely complicated, just kidding, just this very basic function here called add_fn, which takes in those 2 values and returns a sum. And then the UI that I was mentioning is under module-UI, UI.py. And in just about 20 lines of code, I'm able to create the entire front end for this native application. So I'm using Streamlit to build this front end. I'm rendering a title, a note here, I have a couple of forms that accept numbers. These are the two numbers that are going to be added together. And then I pass in those two numbers into the function that I defined earlier, the procedure, so core.add. And that was in our setup script SQL here. And then I'm just returning that value, and that's going to be returned in the front end as well. So that's a quick overview of the logic and the code that's powering this native application. So now let's actually deploy it to my account. So if I navigate to see my native app, I will now type in snow app run. And again, similar to what you saw in the previous demo, just give it a few seconds to run. And if all goes well, you should get a message here in the terminal around whether or not it was successful. And so just waiting for that message. And as you can see now, your application, My Native App, G Hernandez, is now live. Here's that handy link, but you know that I love going back to Snowsite and hitting that refresh button because it's just so satisfying. So I'm going to go back to apps. I'm going to go to packages. And it's already there. So My Native App package, G Hernandez, you can see it was created just now. So that's the application package, which is also populated under the data section of your account. And so you should see it here. My Native App package, G Hernandez. I have a schema called app_source with a stage called stage. And in there, I have all the source code for this native application. And if you take a look at it, you'll see that the directory structure matches exactly what I had locally on my machine. And the reason for that is so that references between objects and code within the native application, they don't break. And so they'll work as intended when you actually install this application in the account. And so let's go back to apps. I showed you the package. And then now you'll see it's that command also installed the application in my account. So if I click on this, I will actually boot up the application and it will start running. So again, just give it a few seconds to warm up. We're loading the front end. And here's those messages that I showed you that we are rendering in that UI. And then let's just add a couple of numbers together. So 1, 2, 3, 4, 5, 6. And you can see here this table. This is just kind of here for the purposes of demonstration. So core.add, I'm showing the two numbers that are getting passed in to that function. And then we're returning the sum here. So 579 for today. So again, with just two commands, I was able to create a native application that pulled in a template for a native app, and then I deployed it to my account. And when I did that, it created the application package for me, and it also installed it. And I'm able to run that application and use it directly in my account. So just wanted to share that and how the Snow CLI tool really is making it super simple to build all sorts of applications using Snowflake, whether that's a Streamlit app, whether that is a native application, these new features, these new tools that Anurag and his team have been working on, just overall, just simplifying the experience for app development on Snowflake. And so with that, with those few demos, I want to pass it back to Anurag because he has a couple of more demos that he'd like to show you.
Hey, thanks, Gulpato. Those were awesome demos. Now let's go to the next part of the demos. We'll show what you can do with our Python APIs. Python APIs is the unified Python APIs across resources for Snowflake. We'll also show how you can use the Python APIs to quickly create and host web services on Snowpark containers. And then last but not least, we'll show a quick demo of how you can manage your database resources like tables, warehouses, and schemas, all within Python itself. So let's get started. So here you can see we already have the notebook. I am running the connections. And once I do the connections, I'm able to easily now define a new compute pool. Along with the compute pool, I'm able to give all the different parameters to assign the min and max nodes. And then in the next steps, you will see my compute pool is created easily. Obviously, with the new APIs, you can use to suspend the compute pool. You can resume the compute pool and to totally manage the compute pool itself. The next step we'll show is how we can fetch an existing image from our registry and use that image to create a service on top of it. So here you can see I was able to upload it. I was able to use this image registry information, which was already uploaded, having the container uploaded. And then next I will go and create a service on top of the compute pool and the image registry itself. So here you can see I created the service itself. The next step is I should be able to get the status of the service. It does take some time. It's still getting spin up. So you can see I already have the service now running, and then you can see it's having that NIGS web service which we wanted to get deployed using that container. The next you can see we can use the Python APIs to suspend the service, restart the service, and then in the end we will show you will be able to get the public endpoint of the service and use that endpoint to actually access the web service itself. So let's go to the next step. Now we see our service is running. The next step is to be able to fetch the public endpoint on our service, which is running in the container. And here you can see the endpoint, which is now available for that service. You should be now able to go to this endpoint and able to see the service running. Let's see, we have it up and running. Let's log in. And then, yeah, here you can see our web server is all successfully deployed, and it's all running within Snowflake in our containers using the image you gave. So this is the power of the Python API, where you can see like simply in the less than 10 steps, you are able to not only provision a new container running in Snowpark, but also be able to deploy a web server all running within Snowflake itself. The next part of the demo is how you can use Python APIs to manage database objects all in a declarative way. So here you can see a quick example of how you can now define database schemas and tables all using Python APIs itself without using any SQL interface. And I'm going quickly and I'm defining a database, I'm defining a schema, and then I'm creating a table, and then I'm doing a quick fetch of the table to see that the table is now created. The next step which I will do here is I will be able to now add declaratively a new column to this table, which is pretty interesting if you see, where now I don't have to worry what's the current state of the table is, but I should be able to now run a create and update. And what does the create and update does? It actually makes sure that on the server side, Snowflake is taking care of the object and able to add the column if the table is already existing, or create the table again if the table was not existing and make sure the column is there. And here, then the last step, you can see that the table was already created, but now we have the new column added all within that. And that's again, another great feature we are adding with Python APIs, where you will be able to declaratively declare all these database objects and be able to use them as you do your deployments or your kind of environment setup for Snowflake. Here you can see the table is now fetched and the table is already updated with the new column, and Snowflake on the backend side make sure if the table is not created, they will create the table and add the column. If the table is already created, they will update the column, and that's the whole power of create and update, which kind of comes inbuilt with the Python APIs. Thanks all for joining today. The last call for action, which you should do, is you should attend the lab which we are doing for Intro to Data Pipelines with Snowpark. And as part of this, you will learn how to build data pipelines with Snowpark, but also how you can automate using our Snowflake CLI for building CI/CD pipelines with that. Thanks all.